Tonight's trends that we're going to be talking about are related to each other, and that would be electronegativity and its reactivity of an atom. So electronegativity, if you look at it, it has the word electron on it, and it really is dealing with and focusing on the electron. And the true definition is the tendency for an atom to attract electrons when it's bonded with another element. So if they had to share these electrons, how likely would those shared electrons tend to stay more on the one element versus another? What I think you guys should think of as right now, because we're really not talking about sharing these electrons until later in this semester or next semester even, is how likely is it to attract or gain electrons? Okay, so how likely is it to attract? And the more likely it is, the more electronegative it is. So when you go down a group or family, what happens is, remember, you're adding these energy levels. So we'll just focus on a few. And when you add energy levels, these outside or these valence electrons become less attracted to the nucleus. In addition, what happens is that other electrons that it would be sharing or trying to gain from, it's not going to happen as much, because when you're far out and these electrons aren't as attracted to the nucleus, they ain't going to be attracting any more electrons. Whereas this guy over here, it's going to be more likely to attract another electron because it itself is attracted to the nucleus more than this guy. So as you go down a group or a family, your electronegativity decreases. As you go across a family, this one, as you go across a, this should not be a family, this should be a period. Okay, cross that off and write period. Okay, as you go across a period, what happens is your electronegativity increases. And this actually makes sense. If you think electronegativity is how likely or the tendency for it to gain an electron, which one's going to want to gain an electron more? If we look at lithium, lithium has one valence electron. It wants to lose an electron, not gain one. If you look at fluorine on the other end, it has 7 valence electrons. It's going to totally want to gain those electrons. So if we're comparing them, lithium really has a very low electronegativity, and fluorine has a very high electronegativity. Okay, and so what happens is you go across a period, your electronegativity increases. Now, what I want you to do as you go across a period, it increases. But what I do want you to note is that these guys, sorry, not these guys in the last column, which are called the noble gases, their electronegativity is equal to 0. Okay, what does that mean? Why is the electronegativity of 0? Well, the reason why their electronegativity values are 0 is because they never want to gain an electron. So if I asked you which one is more electronegative, and I'm comparing oxygen to neon, no matter what, even if I was comparing lithium to neon, neon would never, ever, ever want to gain. So it would always be the lowest compared to anybody else in the periodic table other than the other noble gases. So looking at this, if you want to compare all the electronegativities, which we like to know the highest of everybody, that would be fluorine. So F, or fluorine, goes with E. So F goes with E, F goes with E, F goes with E. Remember, AR goes with FR, so atomic radius goes with francium. Electronegativity goes with fluorine. So if you guys could take out your periodic tables and please circle fluorine and write next to that as electronegativity is the highest. Okay, I also want you to take it out if you haven't done it already and circle FR and put your AR next to it for atomic radius. Now we're going to be talking about reactivity, and once again we have talked about reactivity in the past, but reactivity is how likely are these electrons to be gained or lost within an atom. And for this case, what you want to do is you need to understand what the whole purpose of these elements, what their goal is. On the right-hand side of the periodic table, you were talking about the nonmetals. What is their whole goal? They want to gain those electrons. Who's most likely to gain the electrons? That would be fluorine. So what I want you to do on your periodic table, on your coloring one, I want you to write next to F, I want you to circle it and say most reactive. And it's only the most reactive nonmetal. Why? Because nonmetals want to gain electrons. Whereas on the opposite side, when you're talking about metals, what do metals want to do? Well, metals want to lose electrons. So which one is most likely to lose an electron? That would be francium. So circle francium and circle most and write down most reactive. And it's probably beneficial if you write non-metal. And for fluorine, write most reactive metal. Okay? Why, once again, are they the most reactive? Because F wants to gain electrons the most, and therefore it will react the fastest, and Fr wants to lose the electrons most, so therefore it will be the most reactive nonmetal. All right, hopefully you have a basic understanding that F is the largest as far as electronegativity, and the reasons why. F is also the most reactive metal, and Fr is the most reactive nonmetal. And once again, those noble gases are completely zero when it comes to electronegativity. They are the lowest of the low.